Okay, welcome. Welcome. Oh, that's better. So we have some more presentations for your delight. Hope you enjoyed your lunch. And this is the Riadi. So if you're supposed to be in the Lindsay Stewart, you're in the wrong place. That's the one upstairs. We have Steve Pavitt from Wallet Services. He's going to give a talk to us, a presentation on building trusted business processes with SICAR. Thanks very much.
Okay. Hi, everyone. If you've got any questions halfway through, feel free to sort of just shout and heckle. Always kind of, if you wait until then, you might miss one. Apologies for that smug-looking photo. It's not really who I am, but it's my company photo. Wallet Services is an Edinburgh-based startup. We started as trying to build, well, we're still trying to build cross-organizational workflows on blockchain, and then we've moved away from blockchain more onto a more generic DLT. As we face some of the issues actually using blockchain in a production environment, we kind of moved on to DLT. We've got the two co-founders there. Peter Fay started, he was one of the sort of first guys in Microsoft Scotland, and he helped grow sort of Microsoft Scotland into what it is today. Stewart Fraser, he started a cyber security company and sold to Dell, so there's quite a lot of sort of security and enterprise solutions in there. I myself studied at Napier. This was actually my first campus. I was one of the last students, I think, last computer students to do Napier, but that was a long time ago. So yeah, cool. Moving on, I thought we'd just start with, you know, it's really interesting because cybersecurity is a big thing now, but when I was at uni, we didn't even talk about it. I don't think I did one course on cybersecurity, InfoSec, unit testing. None of this stuff actually existed until I left uni, so I've kind of missed all this. So I've had to learn it all myself and not do it. But I really like, Bush Neer's talking in 2 weeks. I don't know who you know. He's an American cryptographer. Harvard Law, Harvard, MIT. But he's an American cryptographer, and he really knows his stuff. And one of the sort of seminal books on InfoSec that he wrote was Secret and Lies. And in 2000, he was keeping this sort of diary of stuff, I presume, as he was writing it. And this is his first entry. And somebody stole 3,000 customer records, 3,000 credit cards, and this actually got into a book. And if you think where we got from then to where we are now, and this is sort of 19 years later, the last where we are now in the annual breaches, 1,244 millions of records, constantly getting breached. No system seems safe. If you have an attitude of it will never happen to us, it's probably the wrong attitude. It's when will it happen to us and how will we react? And if you look at the big, for quite a while we thought it's okay. We've got Facebook, we've got LinkedIn, we've got Uber, we've got Google. These guys are hiring the best people in the world. They know what they're doing. But actually Uber's been breached, and their breach was fairly straightforward. Somebody managed to grab an administrator username and password, log in as administrator and download all this data. Marriott got breached and they didn't know how they got breached. Facebook's had a couple of sort of small breaches. Amazon's had breaches. Everyone's getting breached because fundamentally we're not solving the issue of protecting our data. It's just not. We either the problem's too complicated for us as humans, or it's the systems are too complicated to be protected. And partly it's because protecting data is really, really hard. It's really difficult. We do lots of different things to protect data. I was having a chat before lunch about GDPR, about how you protect, user accounts, how do you protect it when it goes across countries. Constantly we're looking at how to protect data, and we're losing the battle. We don't seem to actually be even drawing. We are losing. If people want our data, they take it. Either through malicious needs, accidental means. We just are completely unable to protect our data. And I decided I'd steal this from Jurassic Park. it's fundamentally true. Data finds a way. Secrets find a way of getting out. There's nothing we can do about it. Or it seems there's nothing we can do about it. We've got InfoSec now, but we still have problems. We have firewalls now. Didn't really have firewalls in 2000 when I was at Napier. We could look up whatever we wanted. We still have these issues. We don't seem to be answering the question because fundamentally, as soon as people are in our systems, they're grabbing our data. So this is how SICA came about. The guys I joined very early. I was, I think, employee number 4, but I'd been working with identity and security and cryptography for sort of the previous 5 years when I met the guys from Wallet Services. And they're a bit older than me, as you saw on the photo. They were the 2 old guys. And they got to the point where they're really sick of how complicated everything is to do. Yeah? And whenever you try and do cross-organizational work, whether it's opening a bank account, opening a business bank account, if you're multiple directors, applying for a mortgage, numerous things, you constantly are filling out pieces of paper and sending the paper off into the wild and hoping for the best that something happens. And the best you can do, or the best we seem to do as an industry, is we can get that piece of paper and replicate it online and then send it out and just sit back and hope that we get the process completed eventually. So we started thinking about how can we make cross-organizational workflows a reality? How can we protect the data? How can we make these realities? Because the other part of this problem is organizations are really bad at working together. They have real concerns about working together. For example, if you want to be 2 organizations working together, you have to either have some sort of shared, if you're running 2 APIs, you have to have some shared administration, some shared IT. You have to agree, this person's going to own the API and you're going to consume it. If they change it, you have to change it. You're coupling your companies together. That causes issues. Another thing you tend to find is shared identities. You have some sort of shared identities in there, whether it's Jill in accounts is passing it to Steve and somebody else's accounts. We understand too much of the organizational structure, and one of the things organizations like to do, we're no different, everyone else is no different, is organizations like to be able to reorganize to best suit their needs. Whether it's the customer's needs, the business needs, the legal needs, whatever, they want to reorganize, and these shared systems have a problem. Because fundamentally, you've then exposed a bit of yourself to another organization, and then you feel, oh, do we have to tell them? How do we deal with this? How can we protect ourselves? So when we wrote SICA, we set ourselves some really hard, when we were designing SICA, we set ourselves some really hard goals in that we didn't want any shared IT at all between organizations. 1 to N, if you are 2 organizations sharing, there should be 0 shared IT. We didn't want any shared identities. It should be completely decoupled from the humans that work for your organization. And we didn't want any shared administration of the system. You should be able to configure your system, configure your firewalls, and all we need is you to accept how the data going out and the data coming in. And that should be controlled by you. So we set ourselves some really sort of strict rules about if we were going to build SICA, it had to be sensible. So this is what we did. If you look at the modern world, I'll go into this a bit more, I suppose. And this is only 2, but to be honest, in a multi-organizational workflow, there can be 3 or 4 or 5. That could be, and we see this a lot in the public sector. So if you imagine, I'm a rugby coach, I coach my kids' rugby team. To get my rugby club to allow me to coach, I had to fill out a PVG form. It's a sort of piece of paper. That form then got passed to my rugby club, and they got all that information about me. They then had to, the person in my rugby club had to fill in their PVG number. It then went to the SRU, and it sat there for weeks. And the SRU had that piece of paper for ages. Don't know what they did with it. Don't know how good the IT systems are. I don't think they're that good. They may be okay. They may be amazing. Don't know, because there was nothing about it. It then got passed to Disclosure Scotland. And then from Disclosure Scotland, that form maybe got copied into their systems. I don't know. There's no documentation about what they do. Probably went to Police Scotland to do a criminal record check. Probably went to Call Credit to do an address lookup. Probably went to some other agencies within Scotland to determine if I had any, what disclosures they needed. And then eventually, I was sitting there for months and months and months waiting, couldn't do anything, just sitting there waiting, and eventually I got my certificate through, all good. But that's a black box scenario, and that's a bit of paper. And if that piece of paper got lost, it's gone, I had to restart. If somebody had changed that bit of paper, I have to stop and restart. You know, there's no transparency, there's no trackability, there's no traceability, there's no queryability, there's no audit, you know, it's a black box. You're just putting something in the top, waiting weeks and weeks, and it's coming out the bottom. And this is an expensive process. And this process is repeated, whether we're talking about public sector, like Disclosure Scotland, or you're talking about using a mortgage broker, and you know, he takes your data and then he copies the same data you give him into all the different mortgage providers, or you know, anything we're talking about, your data is put in once and it's copied all over, and you have no control of who gets what. And the problem is, we end up being reduced to paper, or if paper's not an option, we tend to end up getting reduced to Excels and emails, which is an unqualified process. We cannot use Excel and email to pass this secure data about because we don't know. And the people that are doing it are trying their best to do the best for the company, but they're not data security experts. They don't know that organisation B needs this bit of data, this bit of data, this bit of data. They're just taking an Excel dump from the database and passing it lock, stock and barrel across. And this is happening every day. Since leaving uni, I've worked for at least 7 organisations, and at least 7 of them, all 7 I know of, apart from Wallet, have sent data across to another organisation in either an Excel or an email or a Word document or a data dump of some sort in an unqualified process. Now, we have data protection officers, we have legal frameworks to protect against this, but fundamentally they're currently so detached from the people doing the job. People just want to get their job done and go home. We have to close this gap. And that's what we want SICA to do. So instead of these decoupled situations, what we really want is, and this is where the DLT comes in, so apologies for sort of waving my hands and shouting blockchain, but this is where DLT comes in. Now, blockchain up till now has been pretty good for one thing, and it's transferring money about and burning, you know, energy resources. We've moved more into DLT, and in fact, we're kind of moving more into distributed register technology, where a ledger is about money and values, a register has data. So for example, one of our transfers will quite often contain personal information, it will contain some documents, it will contain whatever, so our transactions are a lot bigger. But we still need organisation A to connect to organisation B onwards and onwards. So the way we've tried to do this is we've created the SICA platform to do this. So if I start at the bottom, we have our DRT, DLT framework, storage. On top of that, we have our Supernode technology. It's pretty much the easiest way to describe it is it's our enterprise API on top of the DLT. All it's really interested in is transactions. You give it, you give it some data, it makes a transaction, puts it on, and it sends it out. And SICA and Designer are sort of higher level apps, I'd call them, and they sit within an ecosystem of SICA. The SICA Designer, the easiest way to describe it is a workflow builder for cross-organisational purposes. And what we want to do with SICA is we want organisations to come together organically and build processes together. So they identify the actors, who's involved, but not humans. They identify groups within organisations. So if this is a process between, say, myself, who's in product in my company, James, who's in security in Lloyd's, and Tim, who's in GDPR, we wouldn't be trying to send the data to James and Tim because James might go on holiday and Tim might retire, or vice versa. We want to send it to James's department. So if James is on paternity leave or he's on holiday, we can just move somebody in, they can access the data and then pass it on. And the executor is just a standard way of executing these processes. Now, one of the great benefits that blockchain has given us is the cryptography methods with blockchain, in that everyone gets a wallet. But again, we don't want individuals, we want users. So what we've done is, when you deploy SICA, you will deploy it with your identity. It's not our identity, we've got no interest in doing anything with identity. You bring your identity. So if you're using Azure AD, or you're using LDAP or AWS identity, you provide your users, you provide your organizational structures, and then we create wallets that mimic those organizational structures. And they're what we use as actors within SICA. not users, not humans, not applications, but the groups in your organization. And that means if you want to restructure your organization within Sicker, you just leave the group, the wallet alone, and you can restructure. As long as that wallet stays the same, the keys are there. So yeah, we'll go on. Yeah, and so Sicker, so here's a sort of basic view of the designer. We've got title, actors, steps, permissions, and public data. And the permissions is really exciting. And I'm kind of excited to talk about this because this is my favorite thing about Sicker. I'm a bit of a geek. Because fundamentally, when we build systems, and James is there, and he's probably done, actually we've done this together in a previous company, is you'll get your project managers, you'll get your developers, you'll get your testers, you'll get your database admins all together in a room, and you'll build a system. And then you'll go to your management and you'll say, let's deploy the system, this is ready. And then they'll take all that and you'll move off onto another project, and they'll give it to the security department, and they say, make this secure. And then the security department works out the roles in the database and who can do this and who can do that and who can do the next thing. And it increases the time. But the security guys either have to learn what you've all learned that you've discovered in your project, or they just follow, or they do it any way, whatever sensible way they want to do it. But the best people to make that decision are the people building the process. If we can get the people building the process to do it, then we're cutting out this time, we're cutting out this separation, and at the same point of saying we're going to do this, you can agree the contract, the process. We see the process as a contract. So I'll show you I've got a video of Sicker and Design and Execute, and I'll show you this next, actually. Oh no, this is the architecture, sorry. We're totally cloud-based. We think this is the way forward. You can, we have the Sicker Designer identity. Again, that's all provided, you provide your identity, you provide your cloud. And in here, we've got wallet access, transactions. We can connect to other blockchains if you've already got a blockchain platform. One of the things I should say is, everything we do, all our keys are kept away from the users. One of the big problems with Bitcoin, I know James is going to cover this in more detail, but most Bitcoin wallets are compromised when people steal the keys. And as Bill Buchanan quite often says, if you follow him on Twitter, it takes more energy to boil the oceans than break a 256 key. So we don't give users keys. We don't let them see it. We just keep them all. We just generate them, use them, nobody sees them, because you can't lose what you don't have. And then our storage is Mongo. Yeah. So, demo. Let's see if this works, because I've got to... Okay. Play.
Welcome to Sicker demo.
Oh, no, let's turn off the voice.
In oil and gas supply chain. This process involves...
Sorry. So yeah, there's just this was copied from a podcast because I'm too lazy to make my own demos, obviously. So again, with the Sicker Designer, we use a IDP, so we're really seeing the process designer come in here and log in. And the process designer group, I should say, is... A process designer group is a group of individuals identified within the cross-organizational boundaries. Yeah, they are your business analysts. That's who we see it. They've come together, they understand the process you're wanting to build, and it's their job to build this process, and then publish it, and then it's there. So here we see the person editing a process. They put in a title, that's all sort of basics. Then they pick the actors, and these actors are different groups within the different organizations, okay? So operator may well be a group within, this is oil and gas, so operator would be a group within the company requesting the part to be manufactured. The tier one manufacturing is probably the big manufacturing partner they have. Tier two subcontractors is who they subcontract it off. An assurer would be somebody like Lloyd's Register, who's interested in assurance, who's interested in that part is safe to go on the oil rig or to go in the North Sea or do whatever, okay? So we pick actors, and then we generate a series of steps, and each step is what each actor will execute as they go. And because it's a workflow builder, we've got things like date fields, we've got number fields, we've got document uploads, we've got all these different types, multi-options, whatever, and these are represented as you execute the process. This is all very sort of human-based, but I would say you can also this is completely driven by API. If you want, you can have an application, be a member of a wallet, and it can log in and do this. Because the idea is what we want to get to is where IoT devices can write directly to our storage. And then we go on. I'm actually only really interested in showing you the permissioning bit because I think that's where it kind of comes into its own. And we're looking at the processes. Here we go. Come on. Yep, we'll get there. Okay, the permissioning, right? So when these, because this is a transaction, blockchain started as a transaction-based system, and we've implemented a transaction-based system. So when the operator, who is completing step release PO and ITP, populates this data, they're sending a transaction to the next actor, okay? But instead of now, that's not very secure because the next actor is getting all the data. So what we do is when we create that payload, that transaction body payload, we take everything that all the other actors are needing and we encrypt it with their public key. So they're the only people that can decrypt it. So although the data is getting passed into the storage layer and everyone's getting it, unless you have the public key, the private key of the wallet that we've sent it to, you can't decrypt it. Okay? So straight away, the data's getting passed around, but unless you have the right private keys, you can't decrypt it. And the private keys are all kept within each other's organization. Okay? So a private key never leaves an organization. Public keys get transferred, but you need to do that. So, and this is where we see the permissioning adding up. And the other thing I'll quickly say is, as default, everything we put into a second process is encrypted. Nothing is unencrypted. Everything is completely encrypted with the receiver's private key, the receiver's public key. The only difference is if you want to make data public after, you can then decide to make it public after, but not before. So it's secure by default, it's encrypted by default, which seems to be a much securer way of building a system and then wondering what you should do with protection. Do protection first. And then we're going to quickly go through the execution and you'll see the next bit. So here we go to the executor and the operator user logs in and they start the process and they fill out the data. And again, that refers back to what we said the step one was. And because step one doesn't receive data, they don't have any, tier one comes in and they execute and we'll have a look. And that's the data that they expected to put in as part of the step. But according to I've missed it. I'll show it next time. According to the permissions, they receive other bits of data, but they can't change it. They are not allowed to change the data once it's on the chain. If they want to change it, they have to reject the workflow. It has to go back to the original person, and they can update the data, but nobody else can. So this is step 3, and you can see that step 3 needed the PO details, the description of work done, number deduced, date complete, and PO date. And the whole idea is that you only get given the data you need to do your bit. So your attack surface is reduced. Instead of, with the Disclosure Scotland form, getting everything and saving it all because you don't know what else to do and you might need it in the future. If you don't get data, if you only get public data or certain bits of information, then you get breached. Okay, you breached your data store. That's horrible. Nobody wants that. But it's encrypted. And the only data that you're exposed straight away is the public data. That should be non-sensitive straight away. That should be information that nobody cares about. Yeah, okay, nobody wants people to know your PO number or, whatever. But this should be non-sensitive. And this is how we have to start looking at data. We can't just put data into a bucket and create lots of roles for all the responsible people, and then when the hackers come to get it all and they're not responsible, we have to put data straight away into a format which is fundamentally secure, so that it's more hassle for the hackers to hack that data, get that data, and then realize, oh, right, we have to start decrypting it. So every single bit of data also has to have a different key. In case they've managed to access one of your keys, they should only ever be able to access one bit of data. So we always have to be thinking, how do we put data beyond use straight away? So if it is breached or when it's breached, it's not the end of the world for us. It's not an experience situation where they're, scrabbling around desperately trying to, explain themselves. It's, yeah, okay, we got breached. But nobody's reading the data, And this goes on and on and on, and this is how we see processes completed. There's a couple other things that I sort of talked about at the beginning, which was the black boxness of processes, in that if you use multi-organization systems, there's very little you can do to track them. You can call, so what we've already done here is the applicant, and because it's a ledger-based technology, or registry-based technology, we can see all these transactions. We can't see what's happening, but we have access to them all. So we can't see the contents, but we can quite happily grab some metadata and then start reporting as it goes on. And one of the nice things also is because every transaction is written with a timestamp, we can start tracking completion, which means if you're sitting there waiting for a PVG check, or you're sitting there waiting for a part to be manufactured, or you're sitting there waiting, you can come online and you can see where it is. And if it says step 3 takes 7 days and it's only day 3, there's no point phoning them and shouting at them and saying, give me now, because you know it takes 7 days. If it's day 10, that's the point, because a lot of time, especially in the public sector and organizations, we spend trying to deal with people's processes because they do not have visibility. That's a lot of time we have to waste saying people, everyone's called up the bank, everyone's called up the council and said, I've done this thing, where is result of thing, and you spend half an hour on the phone getting past pillar to post and nobody really knows, because they're all different subsystems. The other thing you can do, and this is where public data comes into it, I think, is because everything is encrypted, it is fundamentally unsearchable at this stage. We think that is far more valuable than just allowing people to search anything. So if you make public data, what you can do is you can search it because it's public. So you can be searching for your PO numbers. This isn't sensitive information. This should be public. Anyone should be able to see it and not care. That's what we say is public. Everything that is beyond that level is sensitive. So, and my rule of thumb is really simple. If it was data about me, would I want everyone to know about it? So that's our level. That's how we define public data. Now, because it's a transaction-based system, we do have the ability to build transaction viewers. And this kind of looks like a blockchain transaction viewer if anyone's looked at sort of Bitcoin or whatever. You can go back in time, you can go forward in time, you can see the sender receiver. We've got some transaction metadata. And what we can see here is that, again, this is public. Anyone can see this bit of it. And again, we've logged in as Karina, who did the video. We've got the metadata. Again, it's just tracking information. We've got the public fields, because anyone can see that. And then we get to the important bit, which is the private payloads. And as you can see, Karina is not a member of any wallet. So when she tries to decrypt it, she just gets the raw data. She doesn't have the keys to decrypt this data. So even though Karina's sitting in an organization, she can't see any of the sensitive information. And even if she was the IT administrator, and even if she had all the passwords to all the Oracle databases, if that organization never got sent that bit of data, even if they take it all and dump it in an Oracle data, or dump it in an SQLite database, they don't have access to it because it's encrypted. If you don't give somebody something, they can't get hacked. They can't lose it. So we're wanting to work on at least information privilege. The less you need to do your job, the better. Yeah? And that's it. So that's the end of the video. I'm slightly over time, so I'll just quickly cover these. We've got a few use cases we're working on. We're working on a Scottish renewables, power renewables for replacing old wind farms. The old wind farms that they put up at the early 20th century are all kind of old. But the problem is you can't pull these wind farms down because then you lose all the carbon that you've saved. So they're constantly trying to repair them. So they have, Scottish Power has a deal, they're setting up this shared DLT between Scottish Power, the field engineers, and the different sort of subcontractors they use to do it. Because again, even Scottish Power, they can't enforce this. They don't have an appropriate system, so they can't enforce the system. Other quick process. I'm just coming to the end. Food. Anyone who's read anything about blockchain, you can see there's huge amount in the food industry. We've got a couple of processes going with some partners. Again, public sector, I've talked a bit about that. And finally, the oil and gas, as you can see it. And they all kind of look the same because fundamentally, whenever organizations come together to create shared processes, they have the same issues. And we have to kind of be dealing with them. And a lot of the issues is, how do they create a shared data set that they can come into without compromising their internal organizational structures? Final slide, I promise. I'd say wallet services guiding principles are encryption should be the first and not the last line of defense. If we encrypt first and be sensible with our encryption, then actually breaches become far less concerning, because even if we get breached, nobody can read the data. All data should be treated as confidential unless it's explicitly declared public. I think that model's kind of slowly changing. We're moving that way. Data should be shared on the least information basis. If people don't need it, don't give them it. If you don't need it, don't get it. And again, specifically with keys, you can't lose what you don't have. So that's it. Thank you very much.